Hello. In this video I want to talk about a problem that at first glance may look trivial, but actually has some key elements of programming that pop out when you try to find the solution to this problem. Not to mention I have a personal fondness for this problem since it is partially responsible for my friends and I winning second place in a programming competition. For simplicity, let's call this problem the elevator problem. Here's the setup. Imagine a poorly built skyscraper that contains only one elevator and no staircases. Additionally, this elevator can only hold 3 people at a time. Everyone that works at the building has different floors they need to reach, and as you can imagine, it takes a really long time to get everyone to where they need to be. This is a real drag for everyone that works here. However, after doing this day after day, everyone agrees that things need to change. So instead of doing a first come, first serve system, they decide to find the best solution for everyone. Thus, before going on the elevator, everyone will gather in groups of 3 in such a way that the least number of floors is traveled. So here's the question. What is the optimal way to send people on the elevator? Now might be a good time to pause the video and ponder on that question. If you have thought about it long enough, you may have come up with a solution like this one. Step 1. Sort the people from smallest to largest. Step 2. Group the people into groups of 3. Step 3. Send groups up the elevator. It sounds easy, right? In actuality, this is not the correct answer, or at least not fully. Let me explain why. This solution works great if the number of people happens to be a multiple of 3. But what do you do if it's not? It turns out how you group people becomes a very important decision. You want to make sure the largest numbers get gathered together. Otherwise, you might have unnecessarily long solo trips. So we need a revision to our algorithm. In step 2, what we really need to do is sort people into groups of 3, starting from the largest number. This ensures that our groups are optimal. Now, this simple observation points out something that is a key to programming and problem solving in general that a lot of young programmers struggle with and need to learn to develop. Key idea number 1. Check all cases. Whenever you are solving a problem, you have to be careful that you do not focus too narrowly on a specific example. The solution you make for that example may not carry over to other inputs if you aren't careful. So consider as many examples as you can think of. Another reason our current algorithm is not optimal is that we never said how to send the groups up. Do you notice something though about the elevator trips? On the last one, the elevator doesn't have to come back down because there is no one left waiting for the elevator. Thus, we want to send the largest group up last so that we save the most on floors traveled. So our new step 3 becomes send groups up the elevator, making sure to send the group with the largest numbers last. This points out another key idea in problem solving. Key idea number 2. Avoid arbitrary decisions. There are some cases where the order or the manner that something is carried out doesn't matter, but usually the way we decide to carry out a specific task or action affects the end result. For example, putting peanut butter than jam on a sandwich is much easier than putting jam than peanut butter on a sandwich. For each decision you make, analyze if it is the best way to do that thing. After following good coding practices, we now have our full algorithm. It's a strangely satisfying problem to solve. You start with something so simple, but find beautiful concrete rules that need to be followed. Maybe you don't find this problem as interesting as I do, but hopefully you learned a bit of problem solving skills. And as always, if you want to play with this yourself, I provided code where you can put in your own inputs and see what happens. This time, it's in Python. You can find a link to the code in the description below. Enjoy!